Hey kiddos, hope you're doing well. This video is meant to introduce three types of angle relationships: complements, supplements, and vertical angles. So let's first start with the complementary angles. I'm going to call them complements. And two angles are complementary or complements if they add or sum. Add, of course, add is sum, to 90 degrees. Okay, for example, 50 and 40. A diagram we could use but don't necessarily have to use for that particular complementary angle relationship could look like this. You have two perpendicular lines making 90-degree angle, right angle. And if we kind of bonk another angle in there, an interior angle, then we would say that these two angles, 1 and 2, are complements. Now, these are adjacent complementary angles, but complementary angles in general do not have to be adjacent. They could be. Supplements, supplementary angles, are angles that add or sum to 180 degrees, a straight angle. So again, a diagram we could use, but don't necessarily have to. Sometimes it's helpful for solving problems that involve these supplements, complements, or supplements. Would be this particular diagram here, where we got, a straight angle, and we have two adjacent angles that add up to that 180 degrees. Right? The third type of angle relationship is called vertical angles. And vertical angles are kind of like, well, I got to give you a diagram first. Here's the diagram we usually use, and vertical angles are across or opposite one another relative to this particular diagram. So let's get that down first. They're across or opposite one another, and we'll get into that in a little bit. So for example, let's use this diagram here to the right here. So this angle here is vertical to this particular angle, and I'm going to one-up that. I'm going to make this nice boom, boom. I'm going to make that a nice color here. Oop. And I'm going to make this angle, its vertical angle, the same color. Make it yellow. Construct. Okay, so these two angles in here that, of course, are determined by these two lines, line segments. The red ones are vertical angles. Okay, the white ones are also another vertical angle pair. All right. Red and white, of course, are supplements. Red, white, 180. And red, red are actually the same by what's called the vertical angle theorem. And I'm going to send you another video. If you'd like to, you can check it out, or maybe we'll do it tomorrow, depending on how long this video is, after it's all said and done. The vertical angle theorem says vertical angles are the same. Vertical angles have equal measure or are congruent. Vertical angles are equal. And let's get rid of that underline. So basically from this diagram what we have is these two red angles are vertical angles, and by the vertical angle theorem therefore equal. These two white angles are vertical angles, and by the vertical angle theorem are also equal. Also note, red and white are supplements. Alright, so here's a little problem we can do. Let's start with a little word problem. And I'm going to start out this word problem. The measure of a supplement of an angle is 12 more than than twice, let's get crazy, the angle. Find the angle and the supplement. Okay, so a couple ways to think about this. One is as follows: if the angle is x, then its supplement will be 180 minus x. Right? So if the angle is x, then the supplement will be 180 minus x, right? Because these two have to add to be 180 by supplementary angles. So one way to create a an equation from this word problem is by using that notation. So the measure of the supplement, so that's 180 minus x, equals 12 more, 12 plus twice the angle. So that's going to be 2, and the angle is x. Okay. So the supplement, 180 minus x, equals 12 more than twice the angle, and the angle is called x. All right, I'm going to add x to both sides by the addition property of equality to get 12 plus 3x. I'm going to subtract 12 from both sides by the addition property of equality to get, what's that, 168 equals 3x. Then I'm going to divide both sides by 3 by the division property of equality to get, what's that going to be, 56. Okay, so the angle therefore is going to be 56 degrees. That's x, and its supplement will be 180 minus that, which is, what's that going to be, let's see, 124 degrees. Okay. Now another way to do that would be to set up a diagram, and for those of you who are visual, let's go back, pretend we don't know the answer. We're going to assume that these guys are not only supplements but also adjacent, and so in a similar fashion I can kind of set up, well, I have an angle, x, and its supplement, which is right here, is going to be 12 more than 2x, twice the angle. Okay, now an equation we could set up from here would look like this, right? You're going to add them both up to equal 180. So 12 plus 2x plus the other angle equals 180. And what you'll find, it's the same thing. You get 12 plus 3x equals 180. And that's what we have right here. Okay, so that piece right here is really the same as that piece right here. Okay, so you get the same solution. Just a little different way of thinking about the same problem. All right. Let's look at one more problem, and that's going to be this particular setup. And bada bing, bada boom, we got shunk, and we got a little bit of this, shunk, and we got a little bit of this, shunk, and let's put a point here just to make things fun. Boom, boom. All right. So here's perhaps what we can solve, and this is problem number 2. Let's call this guy 3x minus y. Let's call this guy x. Let's call this guy 50 degrees. And is that enough? Let's call this guy 2x minus 16. All right, so we're going to try to solve for x and y. So check this out. These two angles right here, 50. I'm going to construct an interior, but I'm going to make a little, let's keep that clear. And this angle are vertical angles, right? So if you recall by the vertical angle theorem, these guys are going to be congruent. So by the vertical angle theorem, 50 equals 2x minus 16. I'm going to solve for x. I'm going to add 16 to both sides by the addition property equality. And then I'm going to divide both sides by 2, division property equality, to get x, which is 33. Okay. So now I'm going to plug that 33 in for x here. X is 33. I'm going to just replace it by the substitution property. I'm going to plug a 33 in here for that x. 3 times 33 is 99. Everybody cool with that? And so now I'm able to solve for y because these two angles are also vertical angles. Boom. I'll give you a little different color. And let's make that yellow. Get a little crazy. And so that yellow angle is vertical to this 33-degree angle. Just construct. Right, and so by the vertical angle theorem, I'm going to set up the equation 99 minus y equals 33. Subtract 33, add y, and you end up with y equals 66, of course. All right. So I solve for x, solve for y, and now I can get these vertical angles. Check this out. So that's also 33 degrees. I'm just going to replace that with 33 because remember these have to be equal, vertical angle theorem. And that's also 50. Replace that with a 50 if I so choose by the substitution property. And now I can get the remaining white angles, which are both equal. They're also vertical angles, but 33, 50, and this remaining angle, I'll call it capital A, are all 180 degrees. All right. So 33 plus 50 plus whatever that remaining angle is, all add up to be 180 degrees. That's 83 plus A equals 180. And that makes A equal to, what's it, 97 degrees. Oh. So this angle right here is indeed 97 degrees. Bada bing, bada boom. And by the vertical angle theorem, hey, this other white angle is vertical to this angle A. So this guy is also 97 degrees. Okay. Hey, thanks for watching. We'll pick up with this tomorrow. Have a great day. And I'll send that vertical angle theorem proof. Actually, I'm not going to send it to you. I will go over it tomorrow in class. Thanks for listening. Bye-bye.